In this video we have two equations and we're going to solve them by factoring. Now for the first one we have a third degree equation, polynomial equation, and anytime you have four or more than three terms, normally it's going to be factoring by grouping, even though you could do it other ways. But in this case, let's look at the first two terms. Take out an x squared out of there, leaves me with an x here, and this one gives me a minus 3 here. And we're always looking for common factors here. So here, instead of taking out a 4, I'm going to take out a negative 4, because then the first term becomes a minus, or an x rather, and the 12 leaves me with a factor of minus 3 equals 0. And then we have a common factor here of x minus 3, so we factor that out. We get x minus 3, and we have left an x squared minus 4. Taking out the common factor, x squared minus 4 is left. Is still equal to 0. Got a difference of two squares here, x squared minus 4. So the factors will be the difference and the sum of the square roots of those two terms. So this will be x minus 2 and x plus 2. And anytime you have an equation and you have one side factored out and the other side is 0, and we know that the product of two or more factors is 0 if either one of those factors is 0 or if they're all 0. So normally what we do is just set each factor equal to 0 and solve. So we had x minus 3 could be 0, x minus 2 could be 0, or x plus 2 could be 0. You could have some solutions that are repeated. In this case we have three distinct solutions. So solving each of those linear equations for x, adding 3 to both sides, and this one we get x equal to 3 here. This one adding a 2 to both sides, we get x could be 2. And then the third one adding negative 2 to both sides, we get x equal negative 2. So the three solutions then that would work for this equation. You could always go ahead and check it. But this type, and unless you make a mistake with the algebra, they should check. But you can go ahead and check it. X should be 3, 2, or negative 2. Those are solutions. Now for the next one, we have 1/3 power, 4/3 power. So this is not a polynomial equation here. But you can see here that we got an x squared minus 3x there, and an x squared minus 3x here. So we have a common factor we can bring out. So x squared minus 3x, and the one that's more convenient to take out is the 1/3 power. So what do we have left then? So taking it out of this one, the first term there, this will just give me an x, so it'll be plus 2. And taking out the 1/3 power from this term here, x squared minus 3x to the 4/3, that leaves me with x squared minus 3x to the 3/3. That's an exponent of 1. So this would just be x squared minus 3x. And then we just combine terms there. Got x squared minus 3x to the 1/3. And in the brackets here, we have a 2x squared multiplying through by 2. So it'd be 2x squared. And 2 times the minus 3 is a minus 6x, and a x is a minus 5x. And this should be 0 here. Otherwise we don't have an equation. Equals to 0, equal to 0. Same thing here, we have the product of factors here, two factors equal to 0. So one or both can be 0. So let's set the first one equal to 0, the 1/3 power. This can be 0. So let's just cube both sides. We get rid of the 1/3 power. So cube this side, cube this side. This would just give me x squared minus 3x. And of course, 0 cubed is still 0. And then here, still got an equation equal to 0. We can factor the x. Be x times x minus 3 equal to 0. Again, the product of x minus 3 equals 0, so it means x could be 0 or x minus 3 could be 0. So what does that tell us then? And it tells me that x can be 0 or x could be 3. Now for this one, 2x squared minus 5x can be 0. This one can be 0. So let's just go ahead and factor it first. So I'll take out an x here. Leave with 2x minus 5. So x times 2x minus 5, that can be 0. That product can be 0. So that means that x could equal 0. We already have 0 on this one over here, so we don't have to put it twice. And then 2x minus 5 could be 0. So 2x minus 5 equals 0. Add 5 to both sides and then divide by 2. That gives me then that x could be 5/2. So all I'll do then is add the 5/2 to this one over here. So the complete solution to this one then, that x could be 0, x could be 3, or x could be 5/2. Those are the solutions that satisfy the equation. And notice that that's find the real solutions. Well, these are the real solutions. There's no imaginary solutions in this for these two problems. So thanks for watching. We'll see you next time.